Right. So let us do a small recap once again. Today our topic is going to be the primitive versions for the consumer and the supplier. Okay. So we have the consumer interface and we have the supplier interface, and there are some primitive versions so that this consumer and the supplier can deal with the primitive versions to avoid the auto boxing and the auto unboxing concept, which is going to increase the performance. Okay. Let us do a quick recap. So we need to repeat this auto boxing and auto unboxing. Auto unboxing. The auto boxing is primarily to convert the primitive to wrapper class. Okay. So get acquainted with these words, primitive type. So when you have the primitive data type, and if that data type needs to get converted to the corresponding wrapper class type, which will be taken care of with the compiler itself. You do not have to do anything from Java 1.5. Compiler will take care of this. So there is no burden on the developer. Compiler will do this automatically. That's why it is called as what? Auto boxing. Right? And auto unboxing. Okay, please aware of these words. And auto means automatic, unboxing means the vice versa of converting the wrapper class type, right? Complete opposite of auto boxing. The conversion happens from wrapper class type to primitive type is called as what? Auto unboxing. So you do not have to, fortunately, you do not have to do anything about this. Compiler will take care of this because this is a feature that was introduced in JDK 1.5. And also we know what is a generic type parameter, right? So for any interfaces or for any collection classes, you specify the data type in the form of type parameter. This type parameter is always of what type? Object type. You call them as wrapper class type. So they don't actually, you cannot specify the generic type in the form of primitive types. Okay, always it is object type, wrapper class type. Right, and we have started discussing about the primitive type function interfaces, and we have the predicate, primitive type function interfaces for predicate. We have an int predicate, long predicate, double predicate, and following which we have also discussed about the primitive type function interfaces for function. Okay, there are many primitive type function interfaces, function interfaces. So we have discussed about the int function. So when you learn one thing, everything is going to be the same. Okay, you always deal with the input type. There are 15 types of primitive versions for function. Today we are going to discuss about the primitive versions for consumer and the supplier. First, let's talk about the primitive version for consumer. Again, I am saying if you did not follow the yesterday's class, no issues. Follow the today's class, you will get the complete picture. Everything is going to be one and the same, right? So make use of this opportunity. It is not a new topic, again a repetition in a different way with respect to the consumer interface today. Okay, always do know about the auto boxing and auto unboxing concept. Let's get it started quickly. So let us say that I have a consumer. You know what is a consumer, right? Interface consumer. What I am talking about, the interface consumer. So what is a consumer? Consumer is an interface. It consumes some data. Okay, and it's a developer duty to specify what? To specify the type, data type, right? So data type is in the form of T. And when you say T here, T always talks about what? The input type, right? So let us go back to that after completing the abstract method. So you have an abstract method called public void accept method. This accept method is going to consider the parameter in the form of the T type itself. So this is the normal consumer. This is a normal consumer, and you pass an input. Okay? Input is of what type? T type. Always remember, the ordinary consumer or the normal consumer is going to accept the input in the form of what type? Always the input is going to get accepted in the form of the object type. Object type or wrapper class type, right? But you can write a program on this. You will understand why it is not recommended for some kind of inputs. When I say some kind of inputs, it is this consumer is not recommended for the primitive type inputs. Not at all recommended for the primitive type inputs. Primitive type. Why it is not recommended? But still you can generate the output, but it is not recommended. Why it is not recommended? We will understand that first. Okay. Now let us write a small piece of code on top of this. Let me open the editor. So I have a database. Okay, let me say that I have the array of numbers. Okay, I have numbers like 1, 2, 3, 4, 5. Simple data set I am taking. Array of numbers I have. So what I want to do here is I want to use the consumer. Okay, consumer. This is the ordinary consumer. This consumer is going to accept the input in the form of the object type. Okay, because this is the design. This is how the consumer is designed by the Java 8 people, the Java 8 developers. They designed an ordinary consumer, and they are saying that this ordinary consumer is designed to accept the input in the form of integer type, which is also called as what? Wrapper class type. So I want to write a logic. My logic is, my actual requirement is I want to find the square root of given numbers, right? For the given inputs, I want to do what? I want to find the square root of inputs, given input. How I am supposed to find? I have the list of integers and I want to find the square root. Okay, I can write a code. Okay, I need to accept a number, right? The consumer will not return anything. It consumes, but it will not return anything, right? I will be using this system.out.println statement, and I am just going to multiply the number with the number itself, a into a. I accept one number, right? So a is already there. So let me take this as a. I accept one number from the end user. This number is getting multiplied by itself, so that you get the square of the given input, right? But there is a problem with this code. Let me run this code. I am going to use the for loop. This for loop is the enhanced for loop, which is going to, okay, so I am running this enhanced for loop, integer x in the n array, right? And what I am doing, I am calling this consumer, which is what? Which is I dot accept method is there. So this accept method will accept a data. The data is x itself. Okay, so when you run this enhanced for loop, the numbers from the beginning to the end of this array will get inside this accept method, and this logic is going to get invoked, right? After running this code, you see the output, right? You get the output. Okay, you get the output as expected. So 149. Okay, you are able to see the square root of the given number. Okay, the output is satisfied. And but Java says, internally there is a problem with this code. Okay, what is that problem that we need to identify first? So, sir, you are getting the output. What is the issue with this? That could be the billion-dollar question that is triggering in our mind, isn't it? We are getting the answer. Why we need to modify this? Why you are saying that this logic is not up to the mark? This is a bad logic. Why this is a bad logic? The compiler is always coming into the picture. Okay, the compiler will always come into the picture. Compiler is going to perform some job, some duty because of you, because of your mistake. What is our mistake actually? Right? You are passing the input. If you look at this input, right? Look at this input. Input is in the form of primitive type. Int is what? Primitive. Yes or no? Int is what type? Primitive type. Primitive type, right? The moment, okay, firstly the number 1 is going to get inside this for loop, right? And you are calling the accept method. So this one is of what type? Primitive type, right? So this primitive type is called upon this particular lambda expression, right? So you pass the primitive type, but before you pass this primitive type needs to get changed to what? Object type. So it is just like you're passing int, guys, right? But this consumer is designed to accept the object type, not the primitive type. Consumer is designed to accept the object type, integer type. It is not accepting this type, it is accepting the object type. So what happens, this process, this operation will be taken care by the compiler, and this concept is called as what? Auto boxing. Compiler says, hey, don't worry, I will do the auto boxing for you, right? And this one becomes the object type one. Okay, the one becomes the object type one, right? And after this, what you are doing, you are performing a mathematical operation here. You are using the multiplication symbol, isn't it? This is representing what? The multiplication, right? So to perform this multiplication, this object type needs to get converted to the primitive type, because you can perform the mathematical operation. Whenever you are using Java operators is always perform the mathematical calculations only for the primitive data, not the object type, right? So one conversion is happened there. You do internally compile it auto boxing, right? And to do this, it also done what? Auto unboxing. Okay, AB done. AB means auto boxing, and auto unboxing is also done. Okay, after doing this two operations by the compiler, which is hidden to us, you cannot see this actually because this is happening internally, right? For one data, auto boxing is happening as well as auto unboxing is happening. Two conversions are happening internally without your knowledge. Okay, how many set of data we have? We have what? 1, 2, 3, 5 numbers. We have. For 5 numbers, it has to ensure that auto boxing is happening for 5 times and auto unboxing is happening for 5 times. So even though you see the result in the console, okay, the result is generated with the cost of performance. Okay, performance is going to be down drastically. For the small input, you don't see any difference. For the larger set of data, you will see the big difference. To overcome this, they have introduced what? The primitive version of consumers. Okay, what they have introduced? They have introduced a primitive version of consumers. Primitive version of consumer. Okay, same thing. Even you know that the input is always integer. Always remember, when you know that the input is always the primitive type. When you already know this, the input is always what? Primitive type. Okay, they are saying that go for the primitive version of consumer. What is the primitive version of consumer for the integer? Okay, there is an consumer called interface int consumer. Okay, so this interface int consumer is going to do what? Okay, this consumer is specially designed to accept the input as the primitive type itself. No need to do this to conversion. No need to do this nonsense. Auto boxing and auto unboxing can be avoided. Okay, when you already know that the input is always integer integer numbers which is of primitive type, you can directly use this consumer, which is what? Int consumer. Okay, it is going to accept the input as the primitive type itself. No auto boxing concept and no auto unboxing concept is required. Ideally, what I can do to my program, okay, instead of doing this, instead of using this consumer, I can use the primitive version. What is the primitive version? Int consumer. Okay. This int consumer will not accept any arguments because this is the wrapper class type. This int, the first int is specifying that this consumer is designed to accept the primitive type of integer, right? I can keep the same logic like before. Only thing I can change is instead of using this, I can use this. You are able to follow. Instead of doing this, I can do what? I can do this. But if I run this code, what is going to happen behind the scenes? Okay, it is going to generate the same output, but the performance is increased. Why the performance is increased? Actually, there is no auto boxing and there is no auto unboxing. Okay, let us take this code once again. Okay, and what is the data that it is going to accept? 1, 2, 3, 4, 5. Okay, first one will come inside. This one is accepted as a primitive type, right? This one will go as a primitive type upon A, right? And this one will go as a primitive type. Okay, no conversion is required, no auto boxing is required, no auto unboxing required. Performance wise, it is going to be what? It is going to be top, right? That's why the primitive versions are entered. Okay, so what I'm trying to say is when you already know that the input is always going to be the primitive type, go for int consumer. Okay, like this you have some few other consumers, like, so you have int consumer. Okay, so int consumer. Like this you have the consumer like the long consumer, right? And you have what? Double consumer. So when you can use this long consumer and double consumer, when you already know that the input type is long, You can go for long consumer. So here you have the okay, when you know that the input type is the long type, long array, L equal to, right, 1 L, comma 2L, comma 3L, comma 4L, comma 5L, comma 6L. Then you can go for what? You can go for long consumer. Long consumer. Okay, instead of in consumer, you can use the long consumer to do the same thing. Long consumer, right? J equal to, can use the same operation to right, J equal to, right, instead of int you can use long here and you can use the L here, right? So accept method J dot accept, J dot accept, which is going to accept the long value. That's it, right? So this long data, okay, 1L, 2L, 3L will go as the primitive itself. Internally, no auto boxing and no auto unboxing is happening behind the scenes. Like your double consumer, when you know that the input is already double, use the double consumer, right? So upon saying this, and there are 3 more consumers. Okay, there are totally 6 primitive versions for consumer. We have discussed 3 now, and we are going to discuss the another 3. Okay, which is what? 2 argument versions for consumer. Okay, let us understand this, guys. Okay, I want to give you the real-time example. Let us say that I have the employee, guys. Okay, I am running a software company. Just an assumption. I am running a software company. So in my software companies, I have three employees. Okay, so this is employee 1. Okay, and I have the 2 other employees. Okay, I have recruited 3 employees to run my software company. So employee 1 and employee 2 and employee 3. Right. What I want to do, I want to give the increment to these employees. Right. So there is already the salary constraint is already there for each and every employee. One employee gets one type of salary, the second employee gets second type of salary, third employee will get other type of salary. But what I want to do, I want to give an increment of rupees something like the 500 to each and every employee. So this should get reflected. This 500 amount should get reflected to each and every employee. I would write a logic for that by using the consumer, by consumer, right? So firstly, focus here. What I do, to store the details of the employee, I need a class, okay, that is what? The employee class. So my employees class is going to have only 2 properties, guys. One property is what? String. The name property, name of the employee. I should capture the name of the employee and I should capture the salary of the employee. All right. So for that, I am using the double. So in order to capture the data to the instance variable, in order to assign the values to the instance variable, I need a constructor, right? Constructor always talking about assigning the data to the instance variables, isn't it? I am generating the constructor. Okay. Constructor is generated. To print the meaningful data to the console, I am overriding the toString method. Public string toString. Already the core Java concept, we have discussed this already. Override the toString method, and the overriding is happening to display the name and the salary of the employee in the console. Right? ToString method is to display the data and to assign the values, and these are the properties. This is the my employee class, typical employee class. Right? So now you see. After doing this, I am creating what? 3 employee objects. Okay, let me create employee objects. Employee E1 equal to new employee. Okay, my first employee is Ratna, and Ratna is making, let's say that Ratna is making about 10,000 rupees per month. Okay, and I have 2 other employees with me. Okay, and the employee 2 E2 object and employee 3 E3 object. The employee 2 is Ashwan. Right, let us say that Shashwant is making around 12,000 per month, and let us say that we have a third employee, Jyoti, and let us say that she is making about 11,500 per month, right? And so these are the individual employee objects. So what I'm just doing, I have created 3 employee objects behind the scenes: 1 employee object, 2 employee object, 3 employee object. Okay, these are the objects. So this is what, this is E1, this is E2, okay, this is E1, and this is E2, and this is E3. And after creating these objects, I want to store each and every object to a collection. Okay, so I want to use what? Array list. Array list. Array list is created to store what objects? To store employee objects. I want to import array list. 1 minute. Okay. So this array list is created to store employee object. Okay, let me store by using al.add. So I have 3 employees. I want to store this in the order, in the same order which we have, which the objects are created. So E1, E2, and E3. Done. Right. So the moment I use system.out.println al, okay, I will be getting the details in the console, like Ratna salary, Shashwant and his salary, and Jyoti and her salary. Done. So my requirement is, I want to do what? I want to use the by consumer to give increment of something like 500 rupees. Okay. You know what is by consumer? We have discussed this already, right? By consumer, I want to ensure that this by consumer is accepting the first argument as what? Employee object. It will accept 2 inputs. First input is the employee object input, and the second input is what? The input that I want to take, which is what? Double. It's the increment, the salary I want increment. Okay, I'm giving the first input as employee object. I will pass employee object. The second input is what? The data, which is of double type. What I want to perform? Increment. Right? What I want to do? Let me say that a comma b. If I get 2 inputs like a comma b, right? I want to do what? I want a is of employee type. A is what? Okay, instead of a comma b, let me take e comma d. E is of employee type, right? I want to extract the salary of employee, and I want to do what? I want to use that salary. I want to give an increment of something like what? D, right? Extract the salary and give the increment of D. You pass to one. The first one is talking about the employee object. First parameter is talking about the employee object. Second parameter is talking about the increment, the value the increment value, right? This is the typical lambda expression to give the increment to the employee. So I want to run a for loop, right? My for loop is going to accept the employee object in where employee objects are stored in what? Array list, which is of al. Right? Let me run the for loop, and I want to call this lambda expression increment dot. Okay, let me call increment dot accept method. If this is going to accept the employee object, the second parameter is the increment value, which is what? 500 rupees. Right? Let me run this code. So what will happen behind the scenes? Before increment, this is the result. Okay. After this increment, I want to print. I want to print to check if the changes is reflecting in the employees or not. I'm just printing this once again. Right? Let me run this code once again. So look at this. The first actual salary is 10,000 for Ratna, and now you see the salary 10,500. Right? So 500 is increased, which is actually doing this increment. This by consumer is doing this increment. But there is a problem here with the by consumer. What is that problem? You will understand that. Okay? So the problem that is actually hidden. Okay, that is actually hidden, and the problem that is actually getting solved by the compiler. Okay, so this is the by consumer, right? The first data is of employee type. The second data is of what? Double type. So no issues. So it is going to accept the employee object. When you see the for loop, enhanced for loop here, the first employee object is what? This is the first employee object, E1. Right? So E1 is the first employee object. Okay, and this employee object is going to be like this, isn't it? Behind the scenes. Okay, so there is an employee object, something like this. right? And you have what employee name is going to be Ratna, right? And you have what employee salary is going to be 10,000, right? This is of what type? E1 type. Focus here, guys. E1, right? E1. So this increment logic, the by consumer logic is what? You are passing the E1, right? And okay, this E1, inside this E1, from the E1 you are extracting the salary, E1 dot salary. If you see E dot salary, okay, so you are extracting the salary. Salary is what? 10,000. 10,000 is extracted. 10,000 is extracted, right? So this is okay, because no auto boxing or no auto unboxing is going to be there. This is okay. 10,000 rupees is getting extracted. Okay, you are using the plus operator, right? Salary is 10,000, guys. Okay, and there is a plus operator. And your D is what? D is the value that you are passing here, okay, which is what? 500.00, right? So to make this happen, you are passing the primitive type here. This primitive type, after this calculation, needs to get converted to what type? Needs to get converted to the wrapper class type, which is double. So there is one auto boxing is happening behind the scenes. For one employee object, one auto boxing is happening behind. Without your knowledge, this auto boxing is happening. But you are not doing these conversions. Compiler is reducing the burden for you. Fortunately, compiler is doing this. But unfortunately, because of these compiler operations, the performance is affected. For one employee object, you don't see the much impact on the performance. But if you pass the 100 of employee objects, there is a huge impact for the performance, isn't it? To avoid this, Java people say don't use by consumer if you know you are taking two arguments. Okay? What they are saying, if you are saying taking two arguments, let us say that the first argument is object type. If you know the first argument is object type, and if you know the second argument is primitive type, right? In our example, what is the first argument? Is employee object. What is the second argument? Is double object, right? Primitive type. If this is the case, don't go for by consumer. They are asking you to go for, there is a consumer called object double consumer, right? Object double consumer. Instead of using by consumer, they are asking you to use this object double consumer, right? And this is an interface. Interface object double consumer. Okay, let me put this in the paint screen for better visualization. We will see one example, and after this example, we will try to solve the. You are going to solve the remaining examples. Okay. The interface object double consumer. It has one abstract method, public void accept method. Okay. This accept method is going to accept two arguments. One is of T type, and second one is of object type, and the second one is of what? The primitive type. Double. That's it. You can use this. Okay, when you use this, what is an advantage that you have? You can avoid this. You can avoid what? You can avoid this one auto boxing conversion that has just happened before. You can actually avoid this, right? How you can avoid this? By using that. Okay, we are just trying to replace this. Okay, you are just trying to do what? Okay, instead of using the by consumer, they are asking you to use this primitive consumer. They are asking you to use this primitive consumer. Instead of doing this, let us replay this in our program. Okay, let me remove this logic. Let me do this. Okay, what I want to do, I want to use the primitive consumer. One is object double consumer. Okay, the first is what? The object type employee, right? I just take two argument versions for consumer, right? Okay, when you have the first object as the object type, first input as the object type, and you have the second input as the primitive type, right? Directly use, if you know that the second input is of double type, go for object double consumer, and here you are passing the first input, which is saying that object type, the second input double. Okay, this is talking about the primitive type. Directly you can use this in the logic. Okay, and if you run this code, definitely this is going to do the same job that was done by the by consumer. Okay, by consumer did the same thing like object double consumer, but the advantage of using this is only one advantage that you have. Okay, it is avoiding this auto boxing. Auto boxing is avoided. Okay, here it is doing a lot of auto boxing to convert the answer, which is a primitive type, to the wrapper class type. Here the answer itself is double type, so no conversion is required because the output is being accepted as the primitive type only. So there is no concept of auto boxing here. Auto boxing is avoided. So when you avoid auto boxing, the compiler is avoiding auto boxing, there is a reduction in burden. If there is reduction in burden, there is an increase in performance. Okay, so like this, if you there are many consumers, like there are three other primitive versions: double object consumer, double long consumer, and the last one is double obj double consumer, obj long consumer, and obj int consumer here. These are the two argument customer. If you know that one argument is object type, second argument is primitive type. Okay, if the primitive type is double, you can use this. If the primitive type is long, you can use this. If primitive type is integer, you can use this. Right? So there are only 6 versions of primitive consumers. What are they? Just now we have discussed. Okay, the first 3 versions are int consumer, long consumer, double consumer. Only it is going to accept only one input. When you have to deal with 2 inputs, you can use the by consumer, but when you use by consumer, performance is getting affected. Instead of using that, you can go for this object double consumer, object long consumer, and object int consumer. So totally there are only 6 versions of primitive consumers. The next topic is what? This is going to be very easy now. Primitive versions for supplier. You have discussed about the consumer. The last one is primitive version for supplier. So you know what is supplier already. Supplier will not accept input, but it will supply something to the console. To supply something. So what is that it is going to supply? Okay, let me I want to create a bank application where I want to generate the OTP to the end user. Right? So whenever the end user is trying to make a transaction, complete a transaction, or when he is trying to transfer an amount, what I want to do is I want to protect the security. I want to generate a 6-digit OTP number. So I can generate that by using the supplier. Okay? You know what is supplier? Supplier is not going to accept any input, but it will supply something to the end user. What is that something? Okay, you want to supply the OTP. OTP is in the form of what? Integer. Right? Now focus here. Supplier. Let me import that. Supplier integer. Right? S equal to. It is not going to accept anything. That's why the parameter is empty. And the arrow operator and the lambda expression that is going to supply the OTP. I want to generate a random number. I want to generate a single digit random number. To generate a single digit random number, we already have the inbuilt function which is called what? Math.random. Right? So I want to generate a random number between 0 to 9. So I will be multiplying this with 10. Why I am multiplying with this 10? We have discussed this already in the previous example. Right? So this is going to give the give the output in the form of double, in the form of floating point. I do not want to use the floating point, so I just do the typecasting to convert it to integer. Okay, so when I call this, it will give me an output. Okay, the output could be between 0 to 9. It can be anything. It can be 7, or it can be 6, it can be 3, it can be 1. You cannot guess. You cannot guess this. Right? What I want to do, I want to store the OTP. So I'm using the OTP variable, right? And I want to run the for loop. Okay, I want to generate the 6-digit OTP, isn't it? So I want to run the for loop for 6 times. I equal to 0, I is lesser than or 6, lesser than 6, I plus plus. Okay, and what I am doing it here, I want to concatenate the generated OTP by using the for loop, and I will be calling the supplier s dot get, right? So this will run for the 6 times. This will run for 6 times. Each and every time a random number will be generated. That random number will get concatenated to this variable OTP. Okay. If you see that, if you think the first random number is 6, if you think the second random number is 3, third time 4, fourth time 1, fifth time 5, or 6, sixth time 0. This gets concatenated together and stored in the single variable, which is OTP itself. And if I print OTP, you can see something in the console. Okay. You cannot guess that. OTP generated 397729. And if you run this for the second time, OTP is going to get generated. Each and every time a different OTP is getting generated, right? But there is a problem with this operation. There is what? There is a problem in this. Okay, what is the problem that we have with this? Okay, and this is our code, isn't it? Yes. Right, now you see, guys, right? So supply, it is going to supply integer. Okay, every time this particular mathematical operation is going to give a random number. It could be anything. First time it could be 5, right? This 5 is of what type? This 5 is of what? Primitive type, right? This 5 is of what? Small int type, primitive type. Okay, and what is the supplier is expecting? Supplier is expecting the wrapper class type or the object type. So a conversion is required, don't you think so? A conversion is required, right? This primitive type needs to get converted to what? From this int to integer, and this conversion will be taken care by what? Compiler. So when the compiler is taking care of this conversion from primitive to integer, we call this process as called what? Auto boxing, right? For one number, auto boxing is happening for one time. Okay, the OTP is of 6 numbers, right? So don't you think that auto boxing is happening for 6 number of times? 6 times. Okay, can't I have a supplier which is going to avoid this auto boxing? Okay, I am looking for a supplier that is going to avoid this auto boxing. Right? To avoid this auto boxing, there is a supplier called as what? The int supplier. I can use the same thing. Okay, I can just use what? Int sub. When I know that the output is a return type is integer itself, I can use the supplier called by the name of what? Int supplier. Right? And I can use the same logic. Okay, when you use this int supplier, it is going to do the same thing, but this time this auto boxing is avoided. Okay, the output is integer itself. No conversion is actually going to happen. Okay, so we have some errors here. Okay, and the name of the method is, okay, when the return type is expected as the primitive type, always remember that the abstract method is going to be like get as integer. So get as integer. Get as int. Okay, when you run this code, you will get some OTP, but this time this auto boxing is avoided. What is avoided? This conversion process is avoided. This is avoided. Right, this is avoided. And how this is avoided? So you are using a supplier. The name of the supplier is what? Int supplier. Okay, this is not going to expect any return type, because the output, it is the return type is what? The primitive type itself. So no auto boxing is happening here. Right? Like this, there are 3 other suppliers we have for the primitive versions of supplier. The first one is int supplier. Okay, the second one is the long supplier. Third one is the double supplier. Last one is what? The Boolean supplier. You can practice this. When you already know that the return type is of long type, you can go for long supplier. When you know that the return type is of double type, You can use this. When you know that the return type is a boolean type, you can go for this, right? So for the primitive versions of supplier, there are 4 parts: int, long, double, and boolean. And for the primitive versions for consumer, there are 6 versions, isn't it? So we have what? Obj double consumer, obj long consumer, obj int consumer. And apart from this, you have the int consumer, long consumer, and double consumer. Okay, don't get any panic. I'll just repeat this video once again.